In this lesson, we'll be given an introduction to the exponential function. The basic form of an exponential function is given as y is equal to ab to the power of x plus q. So, y and x stands for the intercepts and q stands for the asymptote. Remember, an asymptote is a line that a graph approaches but will never touch. So a and b tells us more about how the graph will look like. So if a is more than 0 or is positive, we say that our graph will be above the asymptote or above the line of y equal to q, that is above the asymptote. And then if a is less than 0 or negative, the graph will be below the asymptote. Okay, so let's look at the condition for when a is positive. So I'm going to sketch a table here. Okay, so this is for when a is more than 0 or a is positive. There are conditions which can be given to the graph, or what tells us how the graph will look like. Let me add additional lines there. And the last one. So here's the last one. So if a is positive while b is more than 1, this is how your graph will look like. Your graph will be like this. We have the line of y is equal to q. That is the asymptote. The line of y is equal to q. And your graph will be increasing. By increasing, we mean when you are starting from left to right, you are going up instead of going down. This means that our graph will look like this. That is if a is positive and b is more than 1. But if a is positive while b lies between 1 and 0, or b is more than 0 but less than 1, your graph will still be above the asymptote. Okay, but this term will be a decreasing function. The line of y is equal to q, and your graph will be a decreasing function. Remember, you must draw these graphs nicely. This is how your graph will be. If a is positive while b is more than 1, your graph is increasing above the asymptote. Okay, and then if a is positive while b is between 0 and 1, then your graph is decreasing below the asymptote. Okay, I hope this is clear. So, we are going to write other conditions. I hope you understand these ones. So, now let's say a is less than 0 or is negative. We know that the graphs will be below the asymptote. I'm going to give you an example. So, let's say a is less than 0 while b is more than 1. This term here is decreasing. And if b lies between 1 and 0, here it increases. This means that for this case, we're going to say that our graph is below the asymptote. Here's the asymptote. We show it by using dashed lines. The line of y is equal to q. It's decreasing, meaning from right to left. From left to right, you are going down. This is how a decreasing function will be. And here, let's say we have the line of y is equal to q again. This is the line of y is equal to q. Because a is less than 0, it's below the asymptote. And because b is between 0 and 1, our graph is increasing. This means from left to right, you are going up. So the graph will be like this. This is how the graph will look. But it won't touch the asymptote. I hope it is clear. So let's talk about the domain and the range of an exponential function before we do examples. So for an exponential function, for an exponential, the domain is always x is an element of real numbers, and the range is always, so with the range, it's either y is greater than q or y is less than q. I mean y is more than q or y is less than q. So the situations are like this. For y is more than q or greater than q, it's when we have such a situation. If your graph is above the asymptote, you see? But if it's less than q, it's when your graph is below the asymptote. So you must know that as long as your graph, the range is y is more than q, it's when your graph is above the asymptote. But if it's y is less than q, it's when your graph is below the asymptote. Let's have an example. Suppose we have the graph of y is equal to 2 times 3 to the power of x plus 2. I just thought of this thing. I don't know if it makes sense, but let's try to draw it. So first of all, we must know the basic form is given as y is equal to ab to the power of x plus q. You must first know what is your horizontal asymptote. It's given as y is equal to q. This means it's y is equal to 2. That's the horizontal line that the graph must not touch. This is the asymptote. You must first analyze the graph which is given. So let's look at a. Is a positive or negative? Well, it's positive 2. This means that a is more than 0 and the graph will be above the line of y is equal to q. Can you see it? And let's see, this is b. Is b more than 1 or is it between 0 and 1? Well, b is more than 1 and the graph will be increasing. So this is how you can do it. We can say we are drawing the graph now. By drawing the graph, we're going to do it this way. We're going to assume that this is our y-axis and we have our x-axis here. It doesn't have to be to scale, but it must make sense. So let me try to drag it. Yeah. So this is the x-axis and this is the y-axis. And the line of y is equal to 2 must be in this way. So let me see if we can use a different color to represent the asymptote. Yeah, so the blue line represents the asymptote. The line of y is equal to 2. Okay, so let's say this is the line of y is equal to 2. It's the horizontal asymptote. So without even drawing this graph, we know that our graph is going to look like this. It's going to be above the asymptote and it's going to be an increasing function. So you can just go and say the graph will look like this. You'll be correct, but you have to solve for this point which is here. You must have at least 1 point. So how can we calculate it? So this is the origin where the values of x are equal to 0, but the values of y are not equal to 0. So we can solve for the y-intercept because that's where the graph touches the y-axis. That's the y-intercept. And we know that for y-intercept, you let x be 0. So we're going to say that y-intercept x must be equal to 0. And let's solve for y. We're going to have y is equal to 2 multiplied by 3 to the power of 0 plus 2. We know that any number raised to the power of 0 is equal to 1. So we have 2 plus 2, which is equal to 4. This means that here we have 4. I hope it is clear. So this is the graph. This is the exponential function. You can test it using the table method. I know you guys can cheat. You can use the calculator to draw the graph. If you use the calculator, the graph will look exactly like this. So you must know that if a is positive, always your graph will be above the asymptote. But if a is negative, your graph will be below the asymptote. And if b is more than 1, while a is positive, the graph is increasing above the asymptote. And if b is between 0 and 1, while a is positive, the graph is decreasing above the asymptote. And the result vice versa for the when a is less than 0, the graph is below the asymptote. So if a is negative while b is more than 1, the graph is decreasing below the asymptote. But if a is negative while b is between 0 and 1, your graph is increasing below the asymptote. Make sure you're able to work these things. Practice them, and feel free to ask for activities in the comment section and I'll give them to you. Thank you for watching.